and then AN5. This is also can act as an analog to digital converter, input 6, right? So this is using this pin, we are doing a write, slave write, and then also act as a analog to digital converter, 7th input. Then chip select. Maybe this is used for another purpose. Chip select signal. So RD0, WR0, CS0, these can be used together, right? Finally, we have AN7, which is 8th analog input. So all 8 channels, I told, right, you can digitize 8 inputs from different channels using this microcontroller. When you want to interface those analog inputs to this microcontroller, you have to use these pins only, from pin 0 to from pin 2 to pin 10. So these pins are used for analog to digital converter interfacing. That means the sensor input. You can receive input from 8 different sensor in this microcontroller. That is more than sufficient for small implementation right now. But you cannot digitize all of them at same time. You have to do it in a different time. So you have to do a time division multiplexing, right? Then VDD, VSS. So here also we have to provide the same VDD and VSS, 5 volt and ground. Then clock in, clock out. That means you can use pin 13 and 14 to supply a external clock. Again, when you supply a external clock to this particular microcontroller, it can also generate a clock out, because we cannot tap single clock signal to every microcontroller. That's why what they used to do means, when they give some clock input to a controller, they will also expect a clock output. So that's why clock in, clock out pins are there, 13 and 14. When you are not having external clock circuitry, you want to use an internal clock circuitry of microcontroller, you have to supply a crystal oscillator. So if you have a crystal oscillator, you have to connect that one pin with 13, because it used to have 2 pins, one pin with 13, another pin with 14. When you connect that, it will act like a clock source right now. Then here they have said RC not RC1. This immediately they are coming to port to C. Here only 3 pins of port E are explained. After that we come to port to C. Port to C, here it is multiplexed with T1 oscillator output, T1 clock input, T1 oscillator input, catch and compare CCP to CCP1. So those pins are here. Also, these pins can also be used as port to C digital output pins, like RC0, RC1, RC2, like that. Right?
So what is the difference between this clock and oscillator, sir?
Clock means a circuitry which is external. It is able to generate clock pulses with high frequency, right? It is actually a clock circuitry, means a timer circuitry which can generate high PWM pulses. Those can be directly, you can simply tap those clock inputs to microcontroller. Oscillator means you won't have any external clock circuitry to supply high frequency PWMs. Within that external circuitry, no, it is inbuilt. The clock circuitry is already there in the microcontroller itself, but it need a crystal, because they cannot embed the crystal in chip. They cannot do that. That is not possible. Only passive element, and passive element means you can do this resistor, capacitor, these things, and then other op-amp related stuff you can build. gates you can build, but oscillator, inductor, those things you cannot build it in monolithic chip. That silicon wafer, you cannot program crystal oscillator because that is some different material right now. So when your microcontroller chip has internally clock generated circuitry. So clock generation circuitry means they will have some op amps and other stuffs to generate that PWM signal right now, clock PWM signal that is internally available in the microcontroller. Only what it needs is an crystal oscillator that we are connecting in this pin.
So crystal oscillator, the frequency of the highest frequency of the microchip at which the microcontroller works, that is supplied by this oscillator, right, sir? Am I correct?
Yes, actually, what is the maximum operating frequency of microcontroller? That is generated using that crystal. It is actually a piezoelectric material,
Yes,
which
sir.
when you just supply a power, it will generate a voltage pulses. Right now, those pulses are act as a operating clock for this microcontroller. Right. This is oscillator. For that, what you have to do, if you look at any motherboard, there will be a cylindrical or a hex, some sort of rectangle clock will be there. The clock, the crystal oscillator that they choose, no, that will be it used to have a frequency written on it. When you supply power to it, what is the frequency that crystal oscillator will generate? Right. So the crystal oscillator, if it is written as 20 megahertz, means it will generate 20 megahertz frequency. If your chip supports 20 megahertz maximum, means you have to buy 20 megahertz crystal oscillator to connect with 13 and 14. That makes sense now. So when we connect this crystal oscillator, remaining clock generation circuitry is internal to microcontroller. So they will generate a clock and will use it. If you decide not to connect the crystal oscillator alone, you don't want to use the clock generation circuitry of microcontroller, you have an option to supply clock generated by an external clock circuitry, which includes an oscillator. Even every clock generation circuitry require an oscillator as a signal source right now. If they generate those pulses, they can simply supply those pulses in pin number 30.
Okay.
You understood now?
Yes, sir. The clock generation can be done through microcontroller internal circuit.
Yeah.
So
If you generate it outside, you will simply supply that to pin 30. That's it. So microcontroller will take that as an operation clock and will perform every instruction using that as a baseline. Right.
okay. So we are using clock means then what is the use case of this crystal oscillator, sir? If we
Oh,
are
okay,
using the
brilliant. So it is your choice. See, if you want to use a internal clock circuitry, you have an option. Just connect oscillator to 13 and 14 pin and generate the clock. You are somehow, maybe it depends on your application requirement and what for you are going to use this microcontroller. That maybe you already have a circuitry which is generating clocks. Why we have to buy and connect a crystal oscillator here? Why don't we use it from that chips? You can simply connect it to pin 13 so that it will act like a clock for the microcontroller. So when they give some clock in, they also say take some clock out. These clock outs can be used as a reference operating clock for some other electronic module. So your electronic module, electronic chips, another chips, if some chips requires this codecs or analog digital converter requires a clock, means they can supply clock from here. Got it now?
Yes, sir.
Right. So we have RC NAT, timer one oscillator, how to timer 1 oscillator input. I believe this is they use a timer 1 for something that we will study